test the series for convergence or divergence. So the series is so we have polynomials in both numerator and denominator. This is n square and n cube. So if you look at the highest power, in numerator it's n square and in denominator it's n cube. So it goes like 1 over n. So it means we have to compare it with the series with 1 over n. However, if you observe, first note that 1 over n is divergent because it's p series and p is 1 here. So if we try to compare it, if we call it an, now this numerator, and if you write 1 over n here and call it bn, this numerator is greater than n and denominator so here we have to use limit comparison test. Why limit comparison test? Because the standard comparison test, which means that n square minus 1 plus 1 is less than n square minus 1 is less than n square, and in the numerator, and n cube plus 1 greater than n cube in the denominator, so this is less. But because this is divergent, so this does not work. Therefore, we will use limit comparison test. So limit comparison test means, so this is bn, this is an. Limit because 1 over n is in denominator, so n comes in the numerator. So if you factor out an n square, it becomes n cube. Factor out n cube, cancel it, and as n goes to infinity, goes to 0, goes to 0, which is 1 greater than 0. So by limit comparison test, it converges. Or not converges, but diverges. So because this is 1 greater than 0, so by limit comparison test, since Bn is divergent, An is also divergent. So if this limit is positive and finite, then both series either diverge or converge. And because this Bn is divergent, therefore by limit comparison test, An is also divergent. Let's do another problem. Just remember. So the 5 is so this is exponential. So let's call An as now what test we can use? Let's try ratio test. For that we need An plus 1. An plus 1 is next is we compute the quantity, which is the ratio of absolute value of An plus 1 over An, which is there's some cancellation here. If we factor out n, it's square, so we get n square if you factor out an n and it's a square, so you get n square. N square cancel out. So if we now take the limit, as n goes to infinity, this term goes to 0. If with e is greater than 1, so this ratio test implies that when this limit is greater than 1, the series is divergent. Let's do another problem. Number 15. Let's write AK here as if you observe, exponent is k here, k minus 1 here, k plus 1 here. So what we do is we try to make all exponents as k. So we should try to make all as k so that we can use root test. So that we can use root test. Because then k minus 1, k plus 1 is confusing. Now in order to do that, so observe 2 to the k minus 1 is same as 2 to the k over 2, and 3k plus 1 is same as 3k times 3. So then we can rewrite as 3 over 2 because 3 over 2 is a constant, does not have k in it, so I can bring it outside, and this can be written in this form. So then AK is 6 over k. Okay. And if I take the kth root, will be 6 over k, the k divided by k, 6 over k. So the limit k tends to infinity. Zero, which is less than 1, implies convergent. So this is the only tricky part here. Let's do next problem. $19. ln n over root n. So this is an alternating series. So where Bn is and you can see that Bn is positive. Now there are two conditions for alternating series test. So first condition, what is limit and going to infinity Bn. So we can use, so this is what, infinity over infinity form. So we can use L'Hopital. And we get derivative of ln n is 1 over n. Derivative of radical n is so we get limit n tends to infinity. It's cancellation here. 2 over radical n, which is 0. So first condition is satisfied. Second condition is to check if Bn plus 1 is less than Bn. So we have to make let f of x be ln x over x. Now if f derivative x is less than 0, this means f is decreasing function, and that would mean f of n plus 1, which is Bn plus 1, is less than f of n, which is Bn. So we have to compute its derivative and see if it's less than. Quotient rule. So if you just simplify it, you can rewrite it in this form. Now this is less than 0 when ln x is greater than 2. So it means this is, so Pn plus 1 is less than Pn after some finite n. So this condition is also satisfied. So then we conclude that this series is convergent. Because both conditions are satisfied. Let's do another problem. (27) This looks tricky. Let's call AK as one thing we see here is this is less than K ln K over K cube, because K plus 1 cube is greater than K cube and it's in denominator, so which is same as ln K over K square. K cancels out. So let's call this BK. So we can compare it with BK. We can compare with this series. But because it is less than, so it means comparison test will only work if this series is convergent. Because this AK is less than BK. So if this BK series is convergent, then by comparison test, AK will also be convergent. Okay. So then we use integral test to check for the series bk. So we have let f of x is ln x over x square. Integration by parts. So u is ln x, du is dx over x, dv is the remaining part with dx over x square, and then v becomes minus 1 over x. So this integral is because there are two minuses, so it becomes plus. This minus and the minus of the formula. When you substitute t, you get ln t over t. When you substitute 1, ln 1 is 0. As t goes to infinity, this term goes to 0. What about this term? You can use L'Hopital rule. It's 1 over t. This goes to 0, which is 1. Derivative of t is 1. Derivative of ln t is 1 over t. So it means this is correct, that this is convergent. Therefore, AK is also convergent. So convergent. Is convergent by comparison test. Let's do one more problem. 31. This looks confusing, but we can do two things with it. We can either proceed like pull out a factor of like this, or we can also, instead of pulling out a factor of 4, we can pull out a factor of 3. So we can rewrite AK in these two ways. However, this does not work, does not help. Why? Because if we take the limit k tends to infinity, AK, which is limit k tends to infinity 5/4k, this term goes to 0 and this goes to infinity. It means the series is divergent by test of divergence. Because if we take the limit k going to infinity, this will go to infinity, this will go to infinity. So this is infinity over infinity form, which is why it does not help. So we write AK in this form, because then this goes to 0, the 1 here, and infinity. So by test of divergence, it is divergent.